This is problem 530 from the Power PM practice exam. It reads 1000 kVA 12.47 kV to 480 volt transformer with 4% impedance feeds a 480 volt bus. The fault duty of the 12.47 kV system is 40 MVA. Assuming the transformer and the 12.47 kV system have the same XR ratio, the three-phase short circuit current available at the 480 volt bus is most nearly. So let's first work this problem like this fault duty was not provided, and this would be the infinite bus fault calculation. So the first step would be to select your base power and your base voltage. So for the base power, I selected the three-phase value of the transformer. S base equals 1000 kVA, and for the voltage, I selected the secondary side transformer voltage because this is where the fault occurred. And with these two values, we can calculate the base current. I base is equal to S base divided by square root of 3 times V base, and V base is of course the line-to-line voltage value. And this is going to be equal to 1 times 10 to the 6 divided by the square root of 3 times 480, or 1202.8 amps. And this can also be called the full load amps of the transformer, which is the maximum amperage that can be seen through this transformer based on the 480 volts and based on the impedance given for the transformer. And we can use this value to calculate the maximum fault current that could be seen beyond the transformer. And that is going to equal short circuit secondary is equal to I base divided by Z transformer, which is just the 1202.8 amps divided by 0.04, the 4% impedance. That is going to give you 30,070 amps. Answer choice D is actually 30,100, so if you're not careful you could pick answer choice D, but we're not done yet because we need to include the system impedance in our calculations. So let me erase this. So we are given the source fault duty, the 40 MVA. This is not to be confused with the source power rating. This value is actually calculated by using the available short circuit amps at the source multiplied by the line-to-line voltage, primary voltage, and multiplied by the square root of 3. And we can use this fault duty or primary MVA short circuit to calculate the percent Z source. Percent Z source is just equal to the MVA of the transformer divided by the MVA short circuit value, aka the fault duty, times 100. So that is equal to 1 MVA divided by 40 MVA times 100, 2.5%. So now that we have the system impedance, let's go back and use that in order to calculate our secondary short circuit value. So short circuit secondary is equal to I base divided by 2.5 plus the 4% of the transformer, multiply the top by 100, since the bottom two values are a percent, and that is equal to 18,500 amps, and that is answer choice B.